So this is on page 409. Everyone got this? All right, so here's the unit circle. So I just wanted to identify what are the special angles in radians and degrees. So I'm going to go around first in degrees. So you should know that 0 degrees and 360 degrees starts on that positive x-axis. So I'm going to go around in a certain order. I know some people never really memorized the unit circle because you had a note card and you didn't have to, but knowing some of these key angles is kind of important when you get to calculus. So I do the quadrantal angles first. So the quadrantal angles are all the axis angles. So 90 degrees, 180 degrees, 270 degrees, and then you're back to 360. So knowing the quadrantal angles is important. And then I do the 45s next, just so I'm only thinking about these 45-degree angles. So if you count by 45 degrees, it goes 45, then 90, then 135, then 180. If you take 180 and add 45, you're at 225, and then you're at 270, and then you're at 315, and then you're at 360. So knowing the 45-degree angles is important because they all have the same sine and cosine values. It's all going to be root 2 over 2, except they're going to be positive or negative based on which quadrant you're in. Remember, everything's positive in quadrant 1, and then you start getting like a negative x value, positive y value, so it changes as you go around the circle. But if you can pinpoint that these are all 45-degree angles, they all have sine and cosine values of root 2 over 2. So then the next thing that I would do is I would count all the other tick marks by 30s. So 0, 30 degrees, 60 degrees, 90 degrees. So you're counting by 30. So the next one would be 120, 150, 180, and then 210, 240, 270, 300, 330, and then you're back to 360. So it's a way that you can label for yourself the unit circle with the degrees. And then just keeping in mind, all of the 30-degree reference angles are the closest ones to the axis. So 30, 150, 210, and 330 are all 30 degrees away. So they all have a reference angle of 30 degrees. Then the taller angles are all the 60-degree angles, 60, 120, 240, and 300. So if you can kind of keep these in categories in your brain, it'll help you. So when you have to find the cosine of 120, you really only need to know the cosine of 60. They share the same cosine value. So let's just kind of try to recall a radian. So a radian, and actually, I'm going to go to the front page. Do I have the definition here? So the definition of a radian, 1 radian is the measure of a central angle of a circle that intercepts an arc equal in length to the radius. So if I was going to draw out what 1 radian is, if this is the radius, then 1 radian is this angle. So that's a radian if this is equal to the radius. So if I could lay a string around the circle that was equal in length to the radius, I would have 1 radian of measure. So a radian is a geometric relationship between the radius, or actually the diameter, and the whole circle. So the diameter fits around the circle how many times? Pi times, right? So 2 pi times the radius is the circumference, or pi times the diameter. So about 3 times you could fit the diameter, or about 6 times you can fit the radius. All right, so when we're thinking about our unit circle, for radians, this would be 0 radians, and it would also be 2 pi radians. So once around the circle is 2 pi. So the next one that I would do is I always think of 180 next, because that's half of a revolution. So 180 is equal to pi in radians. So if you have to evaluate the cosine of pi, you have to know that it's located over here on the unit circle. And then I would finish with my quadrantal angles. So if this is pi, 90 is pi over 2, and 270 is 3 pi over 2. Does this sound familiar to you? It's been a while. So then I would do the 45s next. So if half of pi over 2 is 45, then this is going to be pi over 4. So you're actually going to count by pi over 4s all the way around. So this is 1 pi over 4. This is 2 pi over 4, which makes 135 3 pi over 4. And that makes 180 4 pi over 4, because 4 pi over 4 would just be pi. So then this is 5 pi over 4. And then 6 pi over 4 reduces to 3 halves. So you'd be at 7 pi over 4, and then 8 pi over 4. You're back at 2 pi. So see, if you count by pi over 4s, you hit all the 45-degree reference angles. So anytime you're taking the sine or cosine of pi over 4, it's just a 45-degree angle. It's root 2 over 2. It's just going to be positive or negative based on which quadrant you're in. And then lastly, I would count by 30s all the way around, and 30 is pi over 6. Because if you think of it, 180 divided by 6 is 30. So pi divided by 6 would be that 30 slice. So this is 1 pi over 6. In my head, I'm thinking 2 pi over 6, but 2 pi over 6 reduces to pi over 3. So this is 1 pi over 6, 2 pi over 6. All the way to the top is 3 pi over 6, which is a half. I'm thinking in my head 4 pi over 6, which reduces to 2/3, so 2 pi over 3. But in my head, I'm holding on to 4 pi over 6, because then this one is 5 pi over 6. So 5 pi over 6, then you're at 6 pi over 6. So you're at pi. 6/6 is pi. All right, so then I'm holding on to 6 pi over 6, so that makes this one 7 pi over 6. And that makes 248 pi over 6 in my head, but I can reduce that to 4 pi over 3. So that's 8 pi over 6 is 4 pi over 3. So then this is 9 pi over 6. This is 10 pi over 6, so 5 pi over 3. And the last one would be 11 pi over 6, because 12 pi over 6, you're back around. All right, so that's the unit circle. So once you know at least where your angles are in relation to the special angles, you're on your way to evaluating the sine, cosine, and tangent of those angles. So the reason we need to review sine, cosine, and tangent of the angles is polar coordinates represent a point in the plane using angles and the distance that you are from the origin. So we're just going to take a brief look at polar coordinates. So we need some of this foundational trig so that the rest of it is going to make sense. So at the top here, it says, let's review where sine and cosine are positive and negative around the unit circle. So if you remember, when you draw your triangle, do you remember that x always relates to the cosine of the angle and y relates to the sine of the angle? Remember, because the unit circle, the unit is 1 for the radius. So if your y value is positive, opposite over hypotenuse will also be positive. So the y value is positive, it makes the sine positive. So in the first quadrant, both sine and cosine are positive because x and y are both positive. So in the second quadrant, now this side of your triangle has a negative value. So if x is negative and y is positive, cosine is negative and sine is positive in that quadrant. So they're both positive, cosine and sine are both positive. X is negative, so cosine's negative. In this quadrant, both sides of your triangle are negative. So both sine and cosine are negative in that quadrant. And I remember that x comma y is in alphabetical order, and cosine and sine is also in alphabetical order. So that's how I remember which one goes with which. And then in this last quadrant, you've got a positive x but a negative y value. So positive x, negative y, positive cosine, negative sine. And I'm not sure if anyone ever told you the phrase, all students take calculus, but all refers to all the trig functions being positive in quadrant 1. S for sine refers to just sine being positive in quadrant 2. Take refers to tangent because opposite over adjacent, double negative would be positive for tangent. So tangent is positive in quadrant 3, and then cosine is positive in quadrant 4. We are not going into the reciprocal identities, cosecant, secant, cotangent this time, but if sine, just to, for your own reference, if sine is positive, cosecant also has to be positive, right? The reciprocal would be positive. Tangent, cotangent's also positive. Cosine, secant's also positive. So I'm not getting into secants and identities, but if you know sine, cosine, and tangent, that's what you need to know for this mini unit. And then this says review the sine and cosine values of quadrantal angles. That's when you take the coordinates of the actual unit circle and refer them to sine and cosine. So this coordinate is 1, 0. I'm 1 unit away from the origin on the x-axis. So that actually gives you the cosine and sine values of 0, or of 2 pi, or of 360 degrees. So if you actually go in and you ask, what is the cosine of 0? The cosine of 0 is 1. What is the sine of 0? 0. What is the tangent of 0? So tangent is sine divided by cosine. 0 divided by 1 is 0. So up here, you're at 0, 1. So now the sine is 1 and the cosine is 0. Over here, you're at negative 1, 0. So that's your cosine and sine. And down here, you're at 0, negative 1. So that's your cosine and sine. So that's why the tangent is undefined. There's an asymptote at 90 degrees, right? If you take the, not in degrees, if you take the tangent of 90, it's undefined because 1 divided by 0 is undefined. So if you don't remember that tangent is sine divided by cosine, that's also a helpful thing to remember. So just kind of peeling back some of your trig knowledge. We're going to do some practice with this tomorrow. So I think I'll wait till tomorrow maybe to do the angles and the relationships. Maybe let's quickly finish the front page though, because this is just the conversion factors. So 360, we already said, is 2 pi radians. 180 is pi radians. If you were going to convert from degrees to radians, you multiply by pi over 180. We already know what 135 is from the unit circle, right? It's 3 pi over 4. But if you didn't know that, you would take 135 and multiply by pi over 180, and that would reduce to 3 pi over 4. Same thing with negative 270. We should know that that's negative 3 pi over 2 in radians, but you could multiply by that conversion factor. And then 315 we should know is, what's that one, 7 pi over 4? So I even have to stop to think because I haven't done this in a year. But what I just did in my head was I thought, okay, 8 pi over 4 would have been the perfect circle. So I just went backwards 1 pi over 4 to get to 7 pi over 4. I'm going to skip converting these non-unit circle degrees and radians because that's really not the focus of our little polar unit here. So let's just do this one right here, the 7 pi over 6. You should know that that is a certain degrees on the unit circle. So how many degrees would 7 pi over 6 be? So you think of it, if you think about pi over 6, it's one of the 30-degree angles. 7 is just past the x-axis, right? Because 7 pi over 6. So it would be 180 plus an additional 30, so 210. And then just being able to graph angles. So 25 degrees, you start on the positive x-axis, and then angles always open, for positive angles, they open counterclockwise. So that would be 25 degrees. Let's see, 13 pi over 6. that would be once around plus an additional pi over 6, right? So it would be really 30 degrees as your reference angle. So it ends here, but it's actually gone once around plus an additional 30 degrees. So the nice thing about graphing on the unit circle is you can show with your direction how many times you've opened from that positive x-axis. So if you're feeling really rusty on the unit circle, maybe you want to redraw that for yourself between today and tomorrow. So we'll talk about these reference angles, I think, next class. And